Okay, so we're going to be simplifying algebraic expressions. And this is very helpful when we have a very complex looking equation later that we want to solve. You always want to make it as simple as possible before you even start solving it, and it makes it less of a headache. So, for example, starting with something like terms. So these are like terms. It's two terms. 2x is the first term, 4x is the second term. And you can distinguish terms between pretty much things that are being added or subtracted from each other. So in this case, I have 2x is one term, 4x is the second term. And when I combine these together, because they are like terms you can tell when you have the same variable and the same exponent. Now, because you don't see an exponent doesn't mean that they don't have one. It just means that it's an invisible one. So in this case, I have 2x and 4x, which if you want to extend it out, the representation looks like this. So 2x means you have two x's that are added together, and 4x means you have four x's added up together. So when you combine them all together, we can say that we have 1, 2, 3, 4, 5, 6 x's. So that's where the terms combining like terms comes from. You technically don't want to always write all of this out. So what we do is we just look at the coefficients. That's the number that tells us how many x's we have. So if you have 2 and then you have 4, you now know that you have 6 of them, 6x. And it works the same with subtraction. If this was a negative, you would just say 2 and negative 4, and you would get your final. Okay, so another thing that we need to acknowledge when we're simplifying expressions is when we want to eliminate parentheses. Say you have 2 times 3x plus 1. And to make this look simpler, it would mean to eliminate the parentheses. And in order to do that, we do what's called the distributive property. You remember this from the past. The 2 is going to get multiplied to everything inside. There's 2 terms inside, so you're going to have 2 multiplication problems. First one is going to be 2 times 3x. That gives you 6x. And then you're going to do 2 times 1, which gives you 2. So this is the simplified version of that first expression. Notice there's no longer any parentheses. I cannot combine these anymore because this does not have an x term, and this one's it's not just a number. So you cannot combine these together. That is as simple as it gets. Now I'm going to go into something a little more complex looking, and I'm going to show you how you can actually make it as simple as a 2-term binomial. Let's do a couple of examples just to get the idea of how this works. So now I have numbers and variables, and it's 1, 2, 3, 4 terms in this problem. I'm going to combine this x term with this x term. My number term goes with this number term. And the underlining kind of identifies which ones are going to go together. So I have a negative 4x and a positive x. You don't see a number in front of the x, but you do have to remember that there's an invisible 1 right there. So if you have 4 negatives and 1 positive, when you combine those together, you're left with 3 negative x's. And I'm just underlining it to match the terms here. And you have 3 and a negative 5. That leaves us with negative 2. Those are the number terms. So notice that we still have our x terms here combined, and then we have our number terms combined to here. They are of different kinds. This one's a constant term, this one's a variable term. We cannot combine those together, and this is our final answer. It's as simple as it gets. So from this to this. Another one, something involving parentheses. So now I see x here, and I see x over here, and I have some parentheses, and I need to make this look simpler, shorter, and easier to do later. So I'm going to multiply the 2, and 2 times x is 2x, and 2 times negative 3 makes negative 6, and that's it for the distributive property. It only goes to the 2 terms inside the parentheses. And now I have my 4x over here that's just going to tag along. It did not involve the distributive property. Now I want to combine 1, 2, 3 terms into something shorter. So I'm going to put this x term with this x term. And those combined together gives me 6x. And this negative 6 doesn't have anything to combine with. It's the only number hanging out by itself. So we're going to tag it along on the final answer. And that is our simpler expression. So we started with this, and now we're ending with this. So therefore it is simpler. And the last one. Two sets of parentheses, and I see x is here and x is here, so it is going to involve a lot of simplifying. The first thing I want to do is get rid of this set of parentheses. So I'm going to distribute the 3, and that's going to give me 3x plus 3. And on this side, if I add the opposite, this is technically a negative 2. A negative 2 times 3x, and a negative 2 times negative 4. That's going to give me negative 6x for the first arrow. The second multiplication is going to be positive 8. So I went from double parentheses to no parentheses just by using the distributive property. Now that I have no parentheses, I see that it's 1, 2, 3, 4 terms that I can also compound it closer or smaller and shorter, putting these terms together. 3x, take away 6x, gives me negative 3x. And if you're not sure how I'm getting this negative 3, I'm just doing integer addition. 3 and negative 6 together is negative 3. And there happen to be x terms, so I just put an x in there. Those are my number terms, or my constants. 3 plus 8 makes 11. This is my final answer. I cannot combine these together. This one doesn't have an x, and this one isn't just a number. So there are different terms that cannot be combined. So to go from something like this to something so simple like this will make our equations later when we're solving so much simpler to solve. So, two things you have to remember. Distributive property and combining like terms. And that's how you simplify any algebraic expression. Now, for a little bonus, some students will think that it's more difficult with a fraction. But at this level, they usually don't give you a fraction if it doesn't work out nicely. So instead of freaking out, which a lot of students do when they see a fraction, you just distribute like you would if it was a number. And because it's a half, you just verbalize it. What's half of 2x? Remember, the word of means multiply. So if you're saying, what's half of 2x? It's like saying, what's 1/2 times 2x? And I know that, and I know that. Half of 2x is just x. Well, what's half of negative 4? That's negative 2. So that's just a little bonus so that when you do see a fraction, you can think of it that way. And if you don't get a fraction that you're comfortable with, you can also just do fraction multiplication. So I'll do this one with fraction multiplication. You can put an imaginary 1 under here, and you end up with 1/3 times 3 over 1. 1 times 3 is 3. 3 times 1 is 3. 3 over 3 is just x. Or, what's 1/3 of 3? Invisible 1, x. Or again, fraction multiplication. 1 times 9 is 9. 3 times 1 is 3. And what's 9 over 3? 3. Again, you can also say, well, what's 1/3 of 9? And if you know that 1/3 of 9 is 3, that's actually a shortcut. So the same thing happens. You have to just remember your fraction multiplication rules.